Hi, my name is Alex Quintanilla and I'm going to be doing solving systems of linear inequalities. Our objective today is graph systems of inequalities, find the maximum or minimum value of a function defined for a polygonal convex set. For my first example, I am going to graph the set of inequalities. As you can see, I highlighted them and changed a couple to y equals mx plus b form so they can be easier to graph. For the first one, y is greater than or equal to 0 is a horizontal line at 0, which is going to be right here. For the second one, the y-intercept is at 2 and the slope is a positive 1, so go up 1 over 1, up 1 over 1 gets you here. For this next one, there's going to be vertical lines at 0 and at 5. For the last one, it has a y-intercept of 6 and it has a slope of negative 1, so you go down 1 or 1 down 1. Since this set of linear equations forms a polygonal convex, you can now go more in depth to finding out maximums or minimums. This is done by this equation, which is x y equals ax plus by plus c. To find the max in the mins, all points of the intersection must get plugged into x and y. So we take the first one, it will be f 0, 0 equals 5, 0 minus 3, 0 equals 0. And then for the next one we take 0, 2 equals 5, 0, parentheses minus 3, 2, parentheses is equal to 6, actually negative 6, and then you plug in 2 and 4, and then you get is equal to 5, 2 minus 3, 4, which is equal to negative 2, and plug in 5, 1, it's equal to 5, 5 parentheses minus 3, 1, is equal to 22, and plug in 5 and 0, which equals 5, 5. Minus 3, 0 equals 25. So the max value of x, y in a polygon is 25. And the minimum is negative 6. The maximum occurs at point 0, at point 5, 0. And then the minimum occurs at point 0, 2. So for example, we're going to be doing a word problem, and I'll read the question. The question says, package delivery services add extra charges for oversized parcels or those requiring special handling. An oversized package is one in which the sum of the length and the girth exceeds 84 inches. The girth of a package is the distance around the package. For a rectangular package, its girth is the sum of twice the width and twice the height. A package requiring special handling is one in which the length is greater than 60 inches. What size packages qualify for both oversized special handling? Now that I've read the question, I will be highlighting the important parts. So what size packages qualify for both oversized and special handling charges when shipping? So first we're going to write two inequalities representing the two charges. So we're going to let L represent the length of the package and G is going to represent the girth of the package. So these are inequalities. L plus G is greater than 84 and L is greater than 60. So now we're going to graph it. So the length is at 84 and the girth is at 80. And I lost my ruler, sorry guys. So it's going to be right here, it's going to be a dashed line because they're not equal to anything and they have no boundaries. And for the second one, it's going to be a vertical line at 60. Which is also going to be dashed. So let me get my highlighters. So this side right here is going to be green because it qualifies for both, since anything to the right of 60 qualifies, and anything above L plus G qualifies as well. So this is going to be a qualifier for both of them. And I lost my highlighter. Where'd it go? So this is going to be yellow because it only qualifies when it's to the right of 60. Anything before that does not qualify. And we're going to do this as blue because it only qualifies when anything above it is it only qualifies when it's above this line. So for example 3, I'm going to be showing that not every system of inequalities has a solution. So for example, y is less than x minus 1. So the y-intercept is at -1, which is right here. And it has a negative slope, so you go down 1 over 1, down 1 over 1, and so forth. And then the y-intercept on that is 3, which would be right here. And it has a positive slope, so you'd go up 1 over 1, up 1 over 1, and so forth. Then we're going to draw the lines. So since the graphs have no points in common, there is no solution.